Here we are with a little bit of homework help for Unit 4, Lesson 1. Let's take a look at the first problem. I'm actually going to come back to this one at the end, so stick around with me. This one's a little bit more complicated than the rest, so I'm going to go ahead and come back to this one. And I know you probably don't want to hear that, but it'll be okay. Number 2, talking about Claire asked Andre to play the following number puzzle. And this is what she got. She said, pick a number, add 2, multiply by 3, subtract 7, add your original number. Andre's result is 27. Which number did he start with? Well, how would I actually work with this? The premise of this lesson is to be able to use some logic and some reasoning to be able to work backwards to be able to understand where we're at. So if we're looking at this piece with it and Andre's final result was 27, we need to be able to work backwards to make that happen. So we had to add your original number, and then we know that the final result was 27. How did he get 27? Well, we have to start with that in mind, and he picks that number. So add your original number. That number, we don't know, so we're going to call that one X. So his final result is 27. We have to basically, if we think about this as an equation, we talk about he ended up with 27 was the final result from picking a number, don't know what it was, but he added 2, multiplied by 3. When we talk about multiplying by 3, we have to think about what already happened, and that was pick a number and add by 2. So we have to think about making that addition happen first, then multiply. And then from that product, we're going to subtract 7, and then we are going to add the final number again to equal X with a final answer of 27. So how do I work backwards from that? Since I don't know what the actual answer was, or the first original number was, I can use my equation to start working backwards to determine X. What I should look at with this is with my numbers, I want to start where I see my parentheses. There's no work inside of these parentheses that I can actually do because the terms aren't alike. So I would take that grouping and I would have to distribute that grouping to 3 times larger. I would need to take the value of 3 and multiply it by X, and the value of 3 and multiply it by 2, which would give me 6 minus 7 plus X is equal to 27. From here, I can look and combine my like terms. This term of 3x would be combined with the plus 7. So I'd be seeing plus x. And then I would be looking at these two values right here of 6 and minus 7. These are both constants. And I take 6 minus 7, and that value would come out to a minus 1 is equal to 27. From here, I find out we have 4 times x minus 1 is equal to 27. And then this gets us to a point where we can go ahead and solve the rest of the equation. We want to get X by itself is our goal to find out the original number. We add 1 to eliminate this constant, make it 0, but we have to add 1 to the other expression as well to make sure that we maintain equality, leaving us with 4 times something is equal to 28, divided by 4 in both expressions, and we say that our number, his original number, was 7. What I need to do with that is go back and double check that that actually is the correct value to go with the situation. So if I pick my number, I take 7, I add 2 to it, 7 plus 2 is 9, I multiply by 3, which is 27, I subtract 7, which gives me 20, and then I take 20 and I add my 7, my original number, back to it, which gives me 27. I know that my answer here is actually 7. And so then I've just put that answer there in the box. Okay. Next question. We talked about in a basketball game, Elena scored twice as many points as Tyler. Tyler scored 4 points fewer than Noah. Noah scored 3 times as many points as Mai, and Mai scored 5 points. How many points did Elena score, and how many points did Tyler score? What I find to work for me on this one is I think about, I have a whole bunch of different people who are scoring a whole bunch of different ways. And like we said, working backwards is often a good result for figuring these things out. we know right off the top that my scored 5 points. Okay. And then with those 5 points, we go back and we want to look right here. And we know Noah scored 3 times as many points as my. So we have Noah is equal to 3 times 5, or 15. We know that Noah scored, Tyler scores 4 points fewer than Noah. So now all of a sudden we can talk about this. We could talk about Tyler is working off of Noah's score 4 points fewer than Noah. And then we can go back and talk about Elena. And Elena's score is going to be twice as many points as Tyler. Simplify those, and you should have your answer. Number 4. Select all the given points in the coordinate plane that lie on the graph of the linear equation. Going back and remembering about this in lesson 3-12, when we talk about the coordinate plane and the points, so the given points on the graph of the linear equation means that we are looking for solutions. And when we talk about solutions, we know solutions are answers to problems. In this case, our solutions need to answer the problem that has 2 variables. So we have 2 answers that need to be there and be correct. We know each of these answers right here represent an ordered pair of x and y. And so we get to use a mathematical property of substitution, which means that we substitute the value of x and the value of y back into the equation. When we look at A, we talk about 4 times the value of x, in this case it's -1 for part A, minus the value of y, which is a -7. Something that I notice and that happens quite often, a common mistake, in fact, my favorite mistake that happens here is we miss the part that this minus sign and the y are separate from each other. You'll notice that when I wrote my equation back in here, you'll notice that what I did is I just kept that minus sign there that was already given, and then I gave the value of y separate from that minus sign. What this does is it helps us to actually account for the value where we see that the x coordinate is -1 and the y coordinate is -7, and we've still kept with the equation that shows that it's 4 times x right here minus the value of y is equal to 3. And with this in mind, now I need to go through it and I need to go ahead and find out, is this a true statement or is this a false statement? If this is a true statement, then A, the ordered pair -1, -7, is a solution that makes this equation true or is a good answer, or answers x and y. So 4 times -1 is -4. The opposite of -7 is +7 is equal to 3. And I know that -4 plus 7 is 3, and 3 is equal to 3. This is true, meaning A is one of the correct answers. We're going to want to go ahead and do the rest of these and check the rest of these to make sure that they're right. I love using these ones that have 0 because I can quickly eliminate a problem or eliminate one of the variables. And in this case, when I look at this one, 4 times x, which is 0 in the case of B, minus the value of y, which is 3, is equal to 3. Is this a true statement? 4 times 0 is 0. 0 minus 3 is equal to a -3, and a -3 is not equal to 3. This B is not a solution, so it should not be one that's checked. Hopefully that helps. Check the exact same process for C, D, E, and F. Find out if there's any other ones in there that are solutions for the equation. Number 5 has 2 different parts. First answer part A and then part B. A store is designing the space for rows of nesting shopping carts. Each row has a starting cart that is 4 feet long. It seems like it's important to me because they said starting cart that's 4 feet long. And when we're talking about nesting carts, I guess I should go back to that. That's like when you go to the grocery store or Walmart or something like that, and you see that you have your one cart with the cool little wheel right here, the cool bar that you ride on in the parking lot, and then the handle. And when we're talking about nesting carts, we're talking about having another cart that this one fits into, and you see that wheel here and that wheel here, and you have more carts that continue to go together. And then you got the person that's out there collecting the carts in the parking lot, picking up those carts and continuously just pushing them in a whole bunch at a time. That's what we mean by nested shopping carts. So that first cart is 4 feet long, followed by the nested cart. So 0 nested carts means that there's just one single cart. The store measures a row of 13 nested carts to be 23.5 feet long, and a row of 18 nested carts to be 31 feet long. So which of the following graphs represents the situation? In this case, what we have to consider with this is the piece about where is our starting value? What do we mean by the starting cart? When we have 0 carts, we might want to automatically think that there are 0 feet, which initially it's true, but the problem is this is not a proportional relationship, and 0, 0 would not be able to be used to represent this situation. In fact, what we're after with this is not this at all. When we're talking about 0 carts, they said so right here. So 0 carts means there's just the starting cart, which means the starting cart is 4 feet. But then we add on another cart, and we have to add on a certain value. In order to understand this, or why is this so important, this helps me to know right away that A is wrong because it starts at 0, 0. We need to have the understanding that all of our information, the number of nested carts with 0 carts, will be represented with starting at 4 feet. But that's not the end of it. We have to be careful with this to understand what is my constant rate that I'm following. 13 carts long is 23.5 feet. 18 carts is 31 feet. So how much does each cart actually add on to it? Well, when we look right here in the inputs, we're adding in 5 carts. And with those 5 carts, we're adding on there 7.5 feet. So what actually happens? Actually, it looks like 8.5 feet. I could be wrong, so hold on just a second. Okay, I'm going to break on this. It's been a long day and my brain's kind of fried. So 31 minus 23.5. Oh, I was right the first time. I should have trusted myself. Let's stay with that 7.5. And then I find out that we add on 7.5 feet for every 5 carts that are given. Well, if that's the case, then how much is it per cart? 7.5 divided by 5 is actually equal to 1.5 feet. So we're adding on 1.5 feet for every cart. That means 3 feet for every 2 carts. So now let's look at our graphs, knowing this information, knowing the slope, knowing the y-intercept. Let's actually see which one of these actually makes sense. We know A is out because it starts at 0, 0. B looks like it starts at 4. C also starts at 4. So now I have to think about something. What's the difference between the two? In C, I see if I rise 6 carts over, well, not quite. Sorry, let's put 6 over 4. That's 6/4. And I know that 6/4 is the same as 3/2, which is the same thing as 1 5/10. So cool, I see the right slope, but I also see the same relationship here. What's different between B and C? Let's look at that. I'm going to have to erase everything. It's getting kind of messy. So what's different between B and C? The next thing I always want to look at is this. I want to pay attention to how am I labeled. I see number of nested carts on Y and then length in the row in feet. There's a difference right there. So let's look and see what does that difference do for us. Is it the number of carts that depends on the length in the row, or does the length of the row depend on the number of carts? In this case, the row is only going to get longer if I add in more carts. So we just eliminated B because this is saying that the number of carts is the thing that's going to depend on the length of the row. We want to look at this and say the number of carts here on the y or x-axis is determining how long the length of the row is going to be. And then just to make sure that we're on the right track, letter D starts at 0, 0 again. Letter D is out. C is the only one that can be correct. That was a lot of work on that one, just to think through it. Number 6, triangle A is an isosceles triangle with 2 triangles. Actually, wait a minute. I think 5 had 2 parts. So that's part A. Part B, how much does each nested cart add to the length of the row? We saw that earlier, 1.5 feet. And if the store design allowed 43 feet for each row, how many total carts fit in the row? Well, keep in mind that the first cart is 4 feet plus 1.5 feet per cart. So make sure you're looking at that piece. If they're talking about 43 feet for each row, then we're saying that we have 43 is equal to the total here. Go ahead and do the math to find that piece. Now we can go to number 6. Triangle A is an isosceles triangle with 2 angles measures x degrees and 1 angle measure y degrees. That means isosceles. If you remember, that means that 2 sides are equal in measure, and then 2 angles measure x. Well, I guess I did that wrong. This is x here. This is x here. I should probably put these ones as something else. Maybe we can call these ones the length is B, the length is B, and then this final one is Y because it says 1 measure of degrees is Y. Complete the blanks with combinations of X and Y that make the sentence true. If Y is 120, then X needs to be what and X needs to be what? We got to remember one critical thing here. Every single triangle that's out there has an interior angle sum of 180 degrees. That's a big deal right there. That means that x plus y equals 180. If I'm starting up here with 120 degrees, that leaves me with 60 degrees to split between the 2 x's. That should tell me these are going to be 30 degrees and 30 degrees. Well, what happens if x is 60? If this is 60, then this is 60. And what's left out of 120 degrees is just what's left up there for y. I think you can work through that. When we talk about the equation, it says complete the equation relating x and y. We're talking about 2x plus blank equals y. Or 2x plus what equals what. Think about back over here to the interior angle sum of the triangle. We know that what they're saying is complete the equation relating x and y. We know that the triangle, the interior angle sum, has to equal 180 degrees. So what we're talking about is twice the value of x plus the value of y is 180 degrees. Right? If you were to sketch the graph of this linear equation, what would its slope be? That's kind of an interesting thought. Right now, this is not in slope-intercept form. This is what we call standard form. So don't be deceived and think that the slope would be positive. Okay? We can't just say that it's 2. What I need you to do with this is transform the equation by subtracting the 2 times x from both expressions, and we get an equation that would look like this. Y equals a negative 2 times x plus 180. And hopefully from there you can see what the slope is. And in the next sentence, it says in the context of the triangle, for every 1 degree of increase in x, y decreases by how many degrees? See if you can get that out of there. I think that it'll work. Think about what the slope is, right? They're saying that in the context of the triangle, for every 1 degree of increase in x, y decreases by what number has to go right here to make this fraction the slope. Okay? Question 7 has, again, 2 parts. A lot of review on this one. We haven't seen a lot of this for a long time. This is really good stuff. It's on here for a reason. Question has 2 parts. First A, then B. Consider the graph, the equations. For each line, select whether the slope is positive or negative. Pretty straightforward. Line L right here. That's blue, line M is black. Tell me the slope. Find each line's exact slope. You have a lot of options for that. You can do calculate rise over run by going from point to point, or you can do change in y divided by change in x, finding those two values. Finally, we're going to go back to number one. This is one that's a pretty heavy question. If you've stuck around this far, you totally deserve the help for this because number one is going to be extra credit. This one is a little bit tricky, okay? Because this one's not as straightforward as everything else. And the fact that you're here for this long video means that you're going to get some points if you stuck in with me. Tyler reads 2/5 of a book on Monday, 1/3 of it on Tuesday, 2/9 of it on Wednesday, and 3/4 of the remainder on Thursday. And I can't get this to move. There we go. If he still has 14 pages left to read on Friday, how many pages are there in the book? We need to pay really close attention to the wording. First off, how many pages are there in the book tells me I don't know how many pages are in the book. So we're going to call that, let X be the number of pages in the book. If he's reading a bunch of pages on Monday, then he's decreasing in the total number of pages that he's reading, but he's decreasing by 2/15 of the book on Monday and 1/3 of the book on Tuesday and 2/9 of the book on Wednesday. But then all of a sudden we get this piece, 3/4 of the remainder on Thursday. That's a little bit funny right there. The wording has changed just a little bit, but here's the other thing with this. The total book, this is the total that he's read altogether up to this point, up to Thursday. Okay? He's read all this here. So we need to consider that all as one grouping together and add those together before we subtract it from the total number of pages. But the problem is we still don't have anything equal. And that's where this comes in to Thursday. Thursday, he has 3/4 of the book remaining. But we know on Friday, he still had 14 pages left on Friday. What we can figure out with this, or what we can decide with this, is that if he's talking about on Thursday, that 3/4 of the book is what he has left. But we can't think of it as 3/4 of X. We have to think about that 3/4 is think about it like this as the book. If we're talking about fourths here, if this is Thursday right here and Friday, he has 14 pages left, that's 3/4 of the book. That means that these other little sections in here, 3/4 would also be 14. So a little bit of a thought right here. It'd be a little bit tricky for how we would write it in the equation. It's more important for us to recognize that if he had 14 pages left on Friday, that's 1/4 of the book because he had 3/4 of the book left on Thursday, which means that 14 pages on Friday, that's the remaining 1/4 of the book, which tells me all of these pages that he has right here read has to add up or equal to 56 pages. This is talking about the remainder of the pages in the book. Okay, now that's awesome that we got it figured out, but the real thing is, what do I do to solve this? There's a few options that we have to do this. I know you're probably looking at the fractions and it's probably worrying you just a little bit. Let's see what happens if we just start punching them into the calculator. If we go like this, 2 divided by 15, and then we're going to come over here and add that to 1/3. Come over a little bit more. Let's get rid of this blue line. And then let's get back to our, oh darn it, sorry. We'll add this one into our calculator and we'll go ahead and add 2/9 into the calculator. Let's just see what we get. Oh man, it's a repeating decimal. That's not going to help us a whole lot. So it looks like we're going to have common denominators. I know that I can take 1/3 and I can make that into a fraction that would be 15ths by multiplying by 5. But I also have 9ths, and the problem is 9 doesn't necessarily go into 15 or 3. They don't really have anything in common. So I need to be looking at a number, a common multiple of 15, 3, and 9 that all these fractions can go into evenly. The first one that I can think of, the least common multiple that I can think of, is 45. So for this first one, or 2/15. 45 divided by 15 is 3, so 2 times 3 is 6. So I'll take 6x plus 1/3 as 45ths. 45 divided by 3 is 15, so 1 times 15 is going to be 15 45ths. And then I know that 45 divided by 9 is 5. Whoops. So 5 times 2 is 10. I add these together, 31 45ths x. Excuse me. I have x minus that is equal to 56. There might still be a little bit of stress on this, but I have a way of helping us out with this one. I know this is 1x right here, but 1x doesn't really help me. What would really help me is if I had a fraction that was equal to 1 and had a common denominator. Because these are like terms, they both have a being multiplied by x. And now what I can do with this is just take 45 45ths and subtract 31 45ths. So we can go 45 minus 31 is equal to 14. That leaves us with this. Whoops. 14 45ths times x is equal to 56. We've done a lot, but the last step is the last step. To get x by itself, we are supposed to actually divide by 14 45ths. What we know from past experience with math, dividing by a fraction is the same thing as multiplying by the reciprocal. So I'm going to change colors here just so you recognize what I'm doing. Multiplying by a reciprocal means that I'm going to multiply by 45 14ths. What this does is this gives me the coefficient is now equal to 1. When you multiply by a fraction by its reciprocal, it equals 1. But I have to consider the same thing on the other expression, 45 14ths. And then I want to get back into my calculator to be able to do this. What I want to do with this is multiply straight across 56 times 45 and then divide by 14. Here we go. 56 times 45 equals 2,520 divided by 14, which equals 180. So now what I'm thinking is there's 180 pages in the book. I'm going to leave it up to you to go back and check to see if I'm right. I know you're hoping I'm right, and I know you're saying you better be right, Quilter, because that was a lot of work. But I want you to double check it by looking at it like this and saying 2/5 or 15ths of 180 plus 1/3 of 180 plus 2/9 from Wednesday of 180 and 3/4 of the remainder on Thursday. We figured out that Thursday and Friday was 56 pages. So we better make sure that all of this adds up to a total of 180 pages. Or you can go back to this point right here where I replace and I substitute. What I've really done is substituted all of the x's with 180. And then what I need to do is be able to add these three values together, subtract them from 180, and it better equal 56, or else we got the wrong answer. I'm going to tell you, have some confidence in me, though. All right, thanks for sticking around for so long. I know this has got to be a long video. Don't you dare give up. We're just in the beginning stages of this, and I'm proud of you, and I'm hopefully you reach out to me for help. So that's it. Have a great day.